the same time. So can we do it 10, 9, 8? You know where it goes, right? All right, let's start. So 10,
9, 8, 7, 6, 5, 4.
3, 2, 1, 0. Boy, you're live. Happy New Year.
Hello, everyone. Hi. That's not me, by the way. That's just our logo. Decided that Spaceman was a good choice, and you know what? They're not wrong. We're going to talk about anti-patterns, and particularly from my experiences, we're going to be talking about the cloud native kind. So let's have a look. Hi, that's me. My name is Bojan Zivic. I'm a community builder with AWS and a director at V2 AI in the modernization space. So what do I enjoy in my own personal time when it comes to non-things AI-wise? I'm a big Argo fan, Carpenter, Kubernetes in general. I know some people are saying, look, there is a place in the world for it, just not at the small places where it costs a lot to run and it's a pain in the butt to run. And people like to make snowflakes. And lately, a big observability guy. CNCF has done a lot of wonderful things. A lot of it has been around the Kubernetes world. OpenTelemetry is not tied to Kube. So anyone can really enjoy it to the point where AWS dropped X-Ray. So that has become the de facto, which is great. But like probably a lot of you, I like AI. I'm definitely AI curious in that sort of case and probably use it more than I should. But at the same time, it's made my life a lot easier. But at the same time, I've also got a GPU at home. So, cost a fair bit. But I like to run my own models as well. So whether it be Qwen, whether it be some of the open source ones or visual models to play with where they're getting, it's fantastic. And if you have a MacBook these days, you can do a lot with very little. But anyway, we're not here to talk about all the wonderful things that I like to do in my spare time. Also, I wrote a book. This is the big thing, but we'll get to that later. We'll focus on anti-patterns. I know the book is talking about anti-patterns, but let me show you a little more. How do we spot an anti-pattern? One of the things I'm trying to get you guys to understand, it's not just about the tech choices. It's about the choices that organizations make when they reach a point where it becomes an anti-pattern, right? Sometimes it comes to the point where it's, something like a tech choice or over-engineering. Other times it comes with, well, this is the best in market and I've seen this everywhere on LinkedIn, right? But the reality is it's a very simple process to look at. It's a bit of mathematics, right? You go Ansible plus Jenkins equals anti-pattern. Very straightforward. If you ever see that, what you want to do, you want to run as quick as possible. But no, seriously, don't use Ansible. Run, seriously. Ansible really should just get burned with a fire. But look, the reason why I say that is in so many cases, this is an example of a tool that was once great for one purpose being repurposed for everything, right? Its intention was to be, hey, let's use this for infrastructure management at scale because we can't do that using these bash scripts anymore. Well, before the world of cloud and infrastructure as code. And then someone said, hey, why don't we do that for cloud deployments? When you meet those people in 2025, you run, like I said. But there are better ways to look at it. It's not tech. A lot of it actually comes down to an emotive recognition of what an anti-pattern is, right? As people, we're emotional and we make choices based on not just what they call our tech choices or our preferences in design. They come from a necessity of, well, the business has picked this. Well, our licensing is this. Well, our vendor is this. And that technically ties strongly due to a calcified bureaucracy. And there's a point that's going to be hitting with all of you. It's going to resonate. Why? Because the definition is things like this. The migration was delayed due to overburden gating. What that means is you had to get 5 different people's approvals to make a change to a DNS record. That's not necessary. But if you work at a bank, or if you work at an FSI, or if you work at any large-scale organization who's very risk-adverse, they tend to add too many gates to the things that just don't make sense. I'll give you an example. How many people here have a dev environment that they work with? Put your hand up. Every single one of you, right? If dev breaks, how many people here would probably get called saying, quick, help, dev has broken? Probably quite a few of you. Those are saying no, I guarantee you it's happened still. So I'll give you an example of what's happened recently. There was a dev environment that broke at one of our CDN providers, wink, wink, nudge, nudge, Cloudflare. Didn't turn out to be dev. You know how that happened? Calcified bureaucracy. Oh, we're going to make some changes. Oh, we're going to prove this to dev. The person reviewing didn't realize it was for prod. And one file away, boom, CDN goes out. But the point is that still happens to this day. So you still have organizations where dev and UAT environments are treated like prod. If there's an outage during the day for it, developers can't work. The modern developer, however, can do most of it from their laptop. I mean, I assume some of you develop locally, use containers, or even just run an NPM server or Golang server, whatever it may be. Yeah. But that's the calcified bureaucracy side. But the legacy foundations are really evident as well. Some of us work at startups and scale-ups, bit of a different story. But I guarantee you probably have your own tech debt that you're dealing with, right? And that's what really the legacy foundations are. It is tech debt, but not from the sense of I made the choice to pick Kubernetes today, so therefore I'm going to, serverless tomorrow. It's more that, it worked like this before. So a great example is the migrations. Well, we had these, VMs on Hyper-V. Now we're going to run them exactly the same in the cloud. And then they wonder, why is my bill so high? Same exact scenario. It's because they're not willing to change. They're tied to a certain process that they don't want to move on. And that's all they stick to. And the fun one, resume engineering. Who hasn't worked on a project before where you just kind of sat to yourself, it's like, there's 30 different tools here that don't need to be here, where it could have been done by one. Or, wow, that was over-engineered. Followed up with, look good on a resume. That is a very evident thing that happens to this day. And especially in the world of AI, where we get a lot of people like, I know what we can do. We can get an agent to do this task. They can process the process. The reality is you probably just need a workflow or a step function or even just a basic function within a monolith to do the job. And a lot of the time, these are decisions based on what good looks like, not what good is. And those are the hardest to avoid. Resume engineering doesn't come from your senior engineers and your juniors who are trying to build. It comes from the top because they want to be like, I led a team that did this bleeding edge technology. There are ways to fight that though. And the solution is culture and communication. Look, not every company is open to being direct with their bosses or kind of going through the means to just have the right to say, hey, that's a dumb idea. But being polite about it is, hey, that's a risk. That puts us in the worst scenario. And the one I like to use a lot is, we're not going to be able to hire for this. So I'll give you a great example, Jenkins. Oof. Find how many engineers actually use it today. Does anyone here use Jenkins? I'll take you to a group. We'll sit down, we'll talk about it, and we'll help you out. It's a bit like therapy, but not therapy. But my point is that's going to be hard. We've got 2 people out of a room of 20. Now imagine the market as a whole. Expand that out to thousands. I need to find a Jenkins engineer. First of all, I need to find someone who's willing to want to look after it. Your CI/CD shouldn't be a snowflake that breaks just because someone did a plugin update, right? My point is that with the right choices now, you can save yourself headaches later. And communication, that ties all back into it. Sometimes you need to make hard choices. If I'm at a place that's got so much tech debt, so many painful things to work with on a day-to-day, I say this as someone who's been a job changer before, maybe it's time to leave. If you can't make the place a better place or you don't have a voice for it, how long have you been there? Do you really want to continue working on it? Because one of the things that you'll run into, and our wonderful recruiter sponsor here can kind of talk to you about it as well, if you don't keep up to date with some of the technologies that are happening and you're being roadblocked by calcified bureaucracy, by resume engineering, or by what we saw earlier, you're not going to be able to move on. So finding a better place definitely comes from choosing to move on. But look, tech recognition still exists. And tech is a big one. Tech is probably what we all probably know best. Like, say, for example, the distributed monolith. Anyone here had to refactor to microservices at some point? Or are they building microservices today? All right, we've got one. Some of you probably have. I know Yao definitely has. I worked with that gentleman there. The idea with microservices was fantastic. We're going to distribute this old monolith into many different containers, functions, what else have you. And we're going to create these wonderful different decoupled layers. So we're going to have queues, we're going to have events, we're going to have all these things. So if one breaks, we can just spin up another copy of it. You know what doesn't change? The database. You know what happens when the database goes down? Everything goes down. We've kind of shifted what was a memory problem to fix into a network problem. Even Martin Fowler, the guy who kind of conned that term, who kind of pushed on everybody, has backtracked. He said, well, go for the macro service, start bundling services closer together, go back to domain-driven design, such a simple and old concept that just makes so much sense, and start segregating out your data layer as well as your compute layer, because compute's easy, especially now with AI. I have a YAML file. Turn this into whatever platform you want to deploy into, right? But the point is that that's one of the easiest things to pick up on. And you yourself as engineers, as project managers, as any other role, should have the ability to know where a blast radius is and how to address it. But data is the hardest. That's why you don't see too many, at least in the world of not the Netflixes and not the Spotifys of the world, a working distributed data plane. Most of the time you see a single master being replicated to many different regions in the hopes that when it breaks, there's been enough messages between them that your RTO and RPO times aren't that bad. Anyone come across a retry storm? Do anyone know what a retry storm is? We've got a few nods. Yep. Oh, I'm going to fail. I'm going to stop. I'm going to fix myself. I'm going to go back and forth and back and forth. You know what another word for retry storm is? Self-DDoSing. Anyone remember Cloudflare recently? That's self-DDoSing, basically. YouTube in 2019, same sort of scenario. Config change that caused a retry storm. Not every function that you build needs the ability to have a retry. And this is something that you're going to hear from me a lot again. If you do proper domain-driven design, where you understand where all your applications live and the bounded context and all the dependencies across each and one of them, you'll know where in the chain to consider a retry. If every single component has a retry function, you have the risk of having a perpetual retry. Now, imagine in the world of AI, someone might have heard me say it, the tokenomics of it, right? Every word costs you X amount. And then you go through the process where now you have a retry storm with AI where you're paying token costs. So your bill goes from, mind you, in the world of cloud, sometimes those bills go up like crazy. You go from $5,000 to $10,000 in a month. In AI, that turned from months to days, to minutes to hours. You're hitting bedrock at a huge level. You're constantly hitting the limits, and you don't know in the background. And then you get a bill of 15 to 20 grand. Well, it's your fault. Just be considerate when you're doing the retry storms, and retries. And just have a think, even from the infrastructure layer, is it necessary? Or do I just need to have something I dump into a queue and worry about it later? One thing I'd really suggest is there's a great podcast called The Pragmatic Engineer. Recently, they actually had Mountain Fowler on there, and he actually talks about this concept. So if you have some time to quickly Google, it's fantastic. And one that we've probably all come across, and it comes with sometimes that title. I've met a lot of great solutions architects in the past, some not so great ones. Lazy architecting. For example, containerization. Let's throw a jar file into a container and call it a day. Or let's try to containerize .NET 4.5 into a Windows container. Terrible thing. But the idea is that people get lazy and just to get a tick inside of a company saying, we're containerized, we've reached this KPI. People suffer for it later. It's lazy development, right? And same sort of scenario when we look at when that container world kind of came to popularity in the 2016s and 17s. Everyone was containerizing and just creating Docker files for every little thing. Most of the time, a VM is just perfectly fine. It's not going to run out. It's not an application that has any sort of garbage collection. Just leave it alone. But no. Containerize the world. Part of the lazy architecting side also comes with the culture that kind of gets ingrained with technology. There's been a big move in the DevOps, SRE, platform engineering side, call it what you want, to start democratizing where the languages get written. No longer is it become a completely separate software engineering team and a completely separate platform engineering team. That platform engineering may have some software functions where it's like, oh, they might be making operators, they might be making some orchestration platforms with some infrastructure as code. The two are basically interchangeable at this point. AI helped bridge that gap, but not completely. Obviously, wouldn't trust one to do the other too much. But there is a fix for this as well. It's very straightforward solution. You probably would have heard about it in the news as well. Really easy to do. You fire a bunch of people and you get AI to replace them. But no. Jokes aside, we all probably heard about Devin, the software engineer AI. It didn't work. Still doesn't work. That's all laughs aside, right? The tech recognitions with cloud-native anti-patterns and how to resolve them are things I've said like nonstop. The key one is really domain-driven design. Now, just because you are doing domain-driven design does not mean that you're moving away from all these other concepts like test-driven design, like even context-driven design with AI. What it is, it's just a way of thinking about how you work with your applications and how you build them. It's not just relevant for cloud-native side. It just happens to work really well with cloud native because your technology choices become easier to make when you know you're working on a fixed and finite point. How many of you here can say that they've got the clean, perfect, fantastic repo structure for all their code? Everyone knows where everything is. You know what helps with that discovery point and makes that easier? That right there, domain-driven design. Because the idea is it's not just about a point of, and this is a big thing, you need to get buy-in from the various stakeholders in the company to say, let's stop developing for a second and let's, if I can be quite frank, unbreak the brakes. Where you start understanding how our code works, what it's doing, where are the main pain points, and how can we start segregating them out and causing, well, less outages. Another old school approach, and look, I know this might not seem like a great decision, but it brings ownership, is an architectural decision record. Not so much being like, we've made this decision and we had 30 meetings to choose to use Ubuntu instead of SUSE because it's cheaper. No. I mean more like assigning ownership to a technology choice. One of the things that people have come through to, I mean, even for example, changing languages, right? Are you all .NET developers here? A lot of you, some of you, cool. Is there a reason to go Java if you're already building everything .NET and everything works in the back end?
No, in my opinion, but that's my opinion.
Well, there we go. But at the same time, if it works, do you need to change it? Same with like, do you need to rewrite everything in Rust? Probably not. Same thing with Golang. All these other things come out that are not net benefits. And when they are, and when all hell breaks loose and you can't hire for them, this is another thing. Rust is a great language. Find me a team of Rust engineers that's not working for one of these mega hyperscalers like your Amazons of the world, and you happen to be a startup. It's difficult and expensive, where .NET engineers are a dime a dozen. Same with Java, same with TypeScript. Python not so much, but it's getting there. Making the right choices will help that. And who to hold them accountable is even more important. Great one to look at is Google's approach in accountability. What they have is something similar to this, but at the micro level amongst the teams. When there's been a key decision choice, whether it be applying a certain framework that's going to have consequences, designing a new tool, or even implementing something into a language, like strongly typed choices, right? They have a owner to that. So the success and failure of it becomes that person's responsibility. So within the team. Why that's important is it really makes you think twice about what you're going to choose, because later on you're accountable. Obviously, I'm not saying to the level of you're going to get fired, but technology choices are probably as important now and 10 times more so important later if they happen to become a headache.
And to combat the resume-driven development.
Oh, yeah. Oh, absolutely. Because then people have to look at it in a year's time when everything's breaking down. They're going, well, why the hell did we do this? Well, I have a decision record that says you thought it was perfect and you ran it against people's mindsets and you fought.
That person's already put that on a resume and moved somewhere else.
No,
I say it half quickly.
No, but that's true. But how big is the IT community? Not that big. It's a small world in Sydney. And you know what happens? Well, when bad architects make bad architectural decisions, they might get hired at one place, but news spreads, don't get hired at many more. I can tell you this comfortably. I've worked with some engineers who are on my own personal blacklist that I will never work with them again. Why? Because they caused some pain and suffering unnecessarily, or their stubborn choices led them to the point where they've caused bigger hassles than benefits. Yet I can say the exact same for others, where there's people I've worked with at 3-4 different companies at this point, where I'm like, my God, you were so great to work with. You made such good decisions, and you were so open to change that I'm more than willing to want to work with you again. So those people who get those resume-driven engineering and get those jobs, they find themselves quickly siloed after a couple of years. You don't want to stagnate your career just because I worked on a cloud-native data mesh, right? It's not relevant. But another one is developer engagement. It's less so a problem now than it was before. In the past, you'd have developers who would be just basically a cubicle and a row of people basically working back to back with potentially some sort of PO or a TL who's basically sitting there and it's helping decide what they're going to work on, how they're going to work, waterfall style, even agile. The problem is that if you're building a tech solution and you don't bring the right culture to that developer engagement side, what quickly happens is that the technology choices suffer because of it. If one person or two people are constantly speaking up, making the tech decisions, you're not getting everyone actively engaged. Now, obviously, there's people who, this is my day job, I don't really care. So why would I want to speak up? But then you find other places that might have relevancy in. You don't know how good you have with people unless you start getting them involved. You'll have data experts, you'll have compute experts, you'll have people who may have been doing in their own spare time. As we found out, we have a guy who works with us who's got I can't believe I'm saying this, 10 GPU cluster at home. He's been building and training his own models, playing with them from day dot, very open source. And it became relevant in a customer project because they wanted to go complete open source. They had the money to do it. So that active engagement, not just through DevRel and having hackathons, but actively communicating and getting others to speak up, helps resolve tech issues, especially when we look at things like, not this, but that lazy architecting. You get more people involved, you have more opinion spread, and you give people a voice to speak up, you're not going to have the tech problems that you have here. But let's look at some real world examples. So this is things that either I've worked at during my time here at Mantle or my time at V2 here, where I've come across anti-patterns that have made me want to pull out my hair. So the first one was an example at an FSI, calcified bureaucracy. So this is the stack that they initially had. It was Puppet with our old friend Ansible. Ansible was actually invoking a Puppet build agent that was basically had no master. So it was just executing a bunch of Ruby-based scripts to build a Docker container that was behind HA proxy. And how they did their updates. Welcome to YouTube. But nonetheless, what we had was this very old legacy setup. And what it was for was actually for RabbitMQ. So they had these Docker images that were being managed and built by Puppet. And then every single time they had to do an update, they went to HA proxy, they dropped one of the nodes, they updated it, they reattached it, and hope it works, right? That's a lot of man hours, woman hours. People's damn time is being wasted. And then they quickly realized after about 7 years, hey, we're on 99.9% of Kubernetes on AWS. Let's move that. So they decided to go for a new model, something modern, something straightforward, something that would require typically less effort, right? Argo CD. So this is more of that pool model where it's like, I'm looking at GitHub and whatever my state is in GitHub, if you have a webhook or if you have the agent, I'll get to that later, I will then reflect that same design in Kubernetes and I will deploy it. And they went with a similar concept called an operator, where it doubles up on Argo CD. The operator would constantly sense check the design of whatever they were building. In this case, it was using the latest RabbitMQ operator. And much like Argo, it would sense check, confirm, do a diff, and then ensure that it stays in a consistent state. You'd think that'd be a perfect state, moving from manual, hand-blown environments, right? The problem is too many people got involved. Not from the sense of technology, but bureaucracy, but bureaucratic changes that created technology issues. So first of all, we're talking about this operator right here. And for those that don't know, an operator in Kubernetes is basically a custom YAML-defined resource file that helps via a controller, again, as I said, ensure that there's a consistency in what you've deployed. If someone drops something, it'll come back up. Someone makes a change that hasn't been addressed by another tool, it'll rewrite on itself, right? Well, it was a custom resource definition that they made for this operator, and it was too rigid. And this specific operator, they only said, well, we designed it that all our applications are on 443 and port 80. Has anyone worked with queuing before at all that wasn't AWS or cloud? Well, let me tell you this much. Queuing doesn't use HTTP and HTTPS ports. It uses port 5162, 63, and 67. 67 being for some stat reports, and it was completely irrelevant. Now, that was just a bunch of custom YAML files. It should be easy to change, right? Well, we'd hope so, but we found out it wasn't. I'll get to that in a sec. Most apps, they used non-HTTP and HTTPS traffic, including the app we're looking at before. The move to cloud had a hard exit date of their data center. So our timelines went from, yeah, you've got a year and a half to, can you do it in 3 months? And the option for the modern things, the easy things, the things that weren't overcomplicated, such as Helm and Kubernetes manifests, were rejected. Not because they were a bad way to do it, but we don't do things this way. And that quickly broke down. Because 2 weeks later, K8's manifests were allowed. Why? Well, we got to prod. We got to deploying. This rigid structure of this is the best way to do things. quickly got broken down when they started realizing, well, you can't put every tech in that same sort of loop. You can't be opinionated to the point where you're forcing changes that are just not going to work. The benefit for us was we got a success story. And at the time, this was a mantle. We got a case study out of it. But the benefit for the customer was we got to change their tech and their engineering approach. They no longer needed these hard and fast tech bureaucratic choices. Technology is democratized. People should have the ability to call out problems rather than being a bureaucratic issue that stops you from making changes for good. And look, this is another example. This is one that I banged my head on the wall for days and days on end. I'm not going to tell you what the customer is, but let's just say the government aligned. They had Argo workflows. They had Ansible, because of course they did. And I'm going to say this now. Those that know what Argo workflow is, it's a execution engine. It's a workflow engine, right? It is basically a way for you to wrap YAML around pretty much almost anything to run steps, kind of like a CI/CD. But then they thought, hey, that's not good enough. Let's wrap that within a wrapper of Ansible, within another wrapper of CDK, which is a wrapper for CloudFormation, which is then going to be written in Node. It's going to reach out to a separate secrets manager that's going to be wrapped again in Backstage. That's just for deploying infrastructure. Now, Backstage isn't the problem. Backstage is just a way for me to go, I'm going to click this one thing here, and it's going to deploy a repo, some architecture, give me some nice basic designs, right? But how much of a mess do you think that would be to unbundle when things go wrong? Massive. You need to go within 10 to 20 different layers of abstraction. It could have been significantly simplified. You don't need Ansible. You don't need Argo workflows. You quite literally just needed CDK or any infrastructure as code for that matter with a CI/CD done. That can just be run from Backstage. The problem was we had a wonderful resume-driven engineering approach that had absolutely no stoppers. The words were, well, you guys are contractors and I work here, so we're going to go with my choices. He lasted 6 weeks. But anyway, it gets worse. There was one repo, another, and another, and another, that Ansible was wrapping. So this guy had somehow decided, hey, this design, rather than having separate invocations with this tool that has the full capability to do it, I'm going to give the keys to the kingdom to this one specific action that has access and the ability to affect 4 different repos. All those repos pulled in infrastructure, pulled in application code, pulled in templates, wrapped them up and deployed them out into another repo, for example, or in this case, to another stack. From a security standpoint, you have the lack of least privilege. From a build standpoint, you are pretending like you know what you're doing. And from a functionality standpoint, if I had to look after that again in the future, I would resign. That's not something you want to work on, but this is a commonality. And a lot of this is that resume-driven design, where my biggest benefit comes from what I can pretend like I'm doing rather than what I am doing. But look, there are a lot of takeaways here and a lot of stuff that I've said, even though it's a cloud-native anti-pattern. It's just general software engineering anti-patterns day to day. The biggest one for me personally is that if there's anything you want to learn from today, if anything that I've said that's going to stick, let it be this. You will spend the next 6 months either fixing these anti-patterns intentionally or being forced to fix them by production outages at 3 a.m. The choice isn't whether to address them. It's whether you do it on your own term or theirs. Because that's exactly what's going to happen. Even if you're at a junior level, even if you're senior, even if you're a non-technical role, if you see an issue, you call it out. If you see an activity that's going to be a headache for you later, don't just kick the can down the road, because that can turns into a boulder that can just not crush just what you're working on day to day, that can generally crush your spirits, because nobody likes working on tech or in an environment where they're just being pushed down by some poor choices. And look, let's be honest, tech is rarely the solution. That is a kicking of the can. Docker is good enough. Do we need Kubernetes? Probably not. Do we need serverless? Probably not. Make some good choices. But the book, yes, the book. All those experiences that I just spoke about and all the wonderful things that I kind of talked about in regards to calcify bureaucracy, I decided to get together with a bunch of people. So myself, Joe Backermeyer, Aidan, and Alan Blocky, all of us are from different parts of Australia. Gerald and I are from Sydney. He's a security community builder. Aidan Ziegler is from Perth. He's a community builder for AWS outside of Perth as well. And Alan Blocky and I, together, we've actually run the community days for AWS in Brisbane. That's coming back next year as well. We've run a couple of meetups here in Sydney as well. And he's one of the ThoughtWorks principals. We decided to get together and be like, hey, we worked with a lot of interesting customers. Let's put our stories of anti-patterns into a book and talk about what goes wrong and how to address it. It's less so best practices around building architecture. It's more what to look out for and the various trenches we've kind of dug through. And that covers it, and that's me. So if you want to connect, got a QR code for my LinkedIn. Give it a scan. Some of you already probably have. Any opinions you want on anything, if you're looking at various meetups you want to talk at, or if you just want to have a chat, hit me up, say hi, and yeah, thanks for listening. Given we've got a bit of time, any questions on anything that's been said so far? Anything at all?
I'll ask a question about the gate versus the ownership to the decisions. So in a lot of organizations, I saw if ownership is assigned to a decision, then people don't make decision and create more gates to protect themselves somehow. So how do you balance this?
The deadline. We need to decide by Friday. Whether or not the choice is good or bad, the decision's been made and someone has to own to it. So people have to commit time to it. So
how do you convince the stakeholder to make a decision that Friday is a deadline?
Well, you don't bring a problem to them, you bring a solution and you ask them for a certain cutoff period and you don't communicate that this will cause a hassle. You go, well, this will slow things down. So I think a lot of the language that we use as engineers is very direct, and that can sometimes be at our detriment, right? Sometimes you need to take a step back and put yourself in the shoes of what would you want to hear if you happen to be extremely sensitive? Because a lot of the stakeholders at the top side, they're constantly being judged upon the function and the final design of what they're doing and what's being actually implemented, and they're worried about what choices they're going to make. You go, look, we have a great concept in mind. We've given you a run through. We've run it by your tech people. Everyone's given a go ahead. Can we hear back from you on Friday? Because if we don't make this choice, it's going to take even longer. So you, in earnest, you provide a solution with a risk profile, with a deadline, and then you work backwards from there. Because then if they go, well, hold on, you haven't done anything. You go, well, hold on, here's this proof and everything that I've given you. I've made your life easy. It's just a yes or no. Sorry.
You guys, so we're talking about one of the things that sticks organizations is sort of having legacy and people saying this is the way we do it. But on the other hand, you gave sort of example of we've got a whole bunch of code working in C#, why should we change it to Java Rust? And these sort of things sort of seem in conflict to a certain extent. Like one saying, why chase something works? But I'm sure you've heard your customers saying, why chase something that works? So I'm trying to work out, perhaps there's more nuance in the book about what really is. And I guess the other example also was like, you sort of presented these quite complex, when you had lots and lots of layers, that was quite complex. Like, now, I'm starting to, my previous work, we use Nix. And Nix, you get to do everything. Now, I know a lot of people don't like Nix. They've got Nix OS, got Nix, it's all Nix. Very
functional, yeah.
Very simple. But I don't think that's necessarily the argument that we should replace or the build system. Sometimes it is. But again, it's like where the anti-pattern is, can't really be decided about the sort of the layers. Sometimes it's maybe better to have more layers because those individual tools are actually better doing the job than having one tool that's bad at all jobs. So I'm just trying to.
I can answer that one.
Yeah.
Great question. First of all, no one wants to write an assembly. This is why we have language abstractions on top of that. You mentioned C#. Why don't you rewrite it to Go? Why don't you rewrite to Rust? That's market dependent. Can I hire for those engineers? So C# might be a maybe, right? You might actually find plenty of people that have it there, or C++ for that matter. Sorry, not C#. Great. You take the choice of, can we hire for these people in case the people who've been here for 25 to 30 years go? Like, for example, has anyone worked on or has known somebody or knows somebody who works on mainframes right now? Yeah, you probably don't because they're probably close to retiring. The average age of a mainframe engineer is in their 60s. So when these systems go end of life and no one knows how to write Fortran, what happens then? C# and C++ are not dead languages. They're still heavily supported. But then you make a market choice at the top level. You don't make it as a level from the technology side where you go, okay, well, can we continue to support this product with the people we can hire and work with today? Has this been community adopted enough where I don't have to reinvent the wheel myself, where someone else will do it for me? The perfect example was the cloud versus on-prem argument. On-premises kind of stayed stagnant, while the cloud providers continued to provide quicker and easier means to more compute, more power in a shorter burst and periods of time. So the rate at which, for example, AWS developed their kit as compared to, say for example, VMware is like over here now. Broadcom have ruined that product. AWS is continuing to make hardware innovations well above, and even software innovations well above what VMware can do now. On the side so that answers that first question with the software side. And the next one is abstraction layer. There is a fine point where you stop abstracting. And that point becomes like, am I just adding abstraction to be complicated and there's no value? Or am I adding abstraction to provide some sort of tangible benefit that's going to increase speed, it's going to increase execution? You need to have that conversation. Because if you don't, and you just basically add an abstraction for no reason, just like Mr. Ansible and Mr. Argo Workflows was over there, you're not adding any benefit. My argument, for example, was I used to love CDK. CDK is an infrastructure as code for writing in any language you want to deploy to AWS. TypeScript, Python, sounds all wonderful at first, right? Oh my God, when you get into production, can it cause hell? Because it's so tightly coupled to the way that it designs things that it has a dependency on a dependency, that it generates JSON objects that have to be, if you're using Python, it has to go to use JavaScript libraries to interpret what you've written in Python to execute out CloudFormation. That sounds like hell. Whilst Terraform, whilst Pulumi, whilst OpenTofu is very much API based. I don't have to work on this other abstraction layer. So you need to make some careful choices. That's probably the best way to kind of say it. But you were definitely listening, so I appreciate that though.
Cool.
Any other questions? Anything at all? Awesome. Thanks for listening.
With microservices, well, one of the characteristics or potential characteristics is that sort of they can be technology agnostic, so that you can have a widely different set of technology stacks within the one workplace. But each of the microservices have got supposedly a technology optimized for that particular microservice. How often is that the case, as opposed to say something like the resume driven?
Rarely. I don't think microservices really are that highly optimized. I mean, if you package it in a container, cool, you can run that container kind of anywhere. But that resume-driven engineering side probably doesn't have much to do with it. I think the two are completely isolated. There is a fallacy in our industry, which is that I can run it anywhere. You can, but you can't run it in production. And Kubernetes falls in that all the bloody time. Like, oh, we solved that cloud problem by running Kubernetes across 8 different clouds. You've just caused 8 different bills to come at you, and it's harder for you to optimize that. So I think it's like less focusing on being completely technology agnostic. It's more focusing on what problem am I fixing. So don't take the technology first approach, take the what business problem am I fixing. Because I hate to say this reality, and for some of the 3 people that are in the online chat, there's actually people online, so hooray.
Yes, I was just going to raise those. Have you got them up already?
I do no comments yet, but I will say this so everyone's listening. If you know how to perfectly define your business problem in a way that's easily interpretable, AI can get you 80% of the way there with something like Claude Code. Then you just need to have enough contextual language skills and software engineering chops to turn that into prod. There's a reason why there's so many people bringing out so many products, the whole enshittification side of things. But it's the whole monkeys with the typewriter approach. If you give enough time and enough monkeys a typewriter, they're eventually going to write Shakespeare. The same thing is happening now in tech. People are like, oh, AI is causing lazy developers. Well, no, if we create about 42 million different applications, give or take, one is going to come out that's going to supersede and be better than anything we've made. So at the rate at which we release is quicker. So knowing business problems and understanding what you're actually trying to fix is 10 times more important than ever was before. And on that note.
Oh, actually, so you do have some questions from our online friends.
Cool.
So Andrew's got the question, what's your opinion about Vercel platform?
Vercel?
Yes.
It's interesting. So Vercel is another abstraction provider on top of AWS. Not essentially a bad thing either, because it gives you things that For example, serverless within AWS doesn't give you. It gives you dependency management out of the box. They also do quite a lot of their own engineering. So if you're building like UIs relatively quickly, especially on the AI side, they decide to go all in. It's great. The downside is in Australia, it's not a heavily supported or a heavily marketed for product. It's gaining some traction now, but there's still only about 1% or 1% of jobs out there. I think if you're trying to quickly prototype and quickly design something, they're fantastic. But just like with Cloudflare's workers, which is a concept that was meant to compete with Lambda functions, Google Cloud Run, and Azure's equivalent, what they call serverless, the product is just not there because there's not enough people using it. Would I put it to production? For certain cases, yes. Would I put it to production for everything? Probably not. It is a great product, though. You need things like that to kind of compete with the other cloud players, even if they're running the kit on the cloud players. Cool.
That's good. And you had another question on, I think, tied to your question. So Andrew said, thank you for great answers. So there you go.
Cool.
But yes, the other question is on what would you use for doing an MVP these days, like Lovable or some other tool or something was the question.
Lovable's fine. I'd honestly be extremely lazy and probably start working with Claude Code to do it. That's what I do myself. So AWS has this program called PACE, which is this rapid accelerated approach to doing prototyping. And one of the tools that we've done is less so focusing on a framework, more so focusing on what can I build with Claude. So with APIs, I've been using Fastify because it's something I'm very comfortable with and building with. With agentic frameworks, I've been using LangGraph mainly because I like to have the ability to do the human in the loop when I need to, as well as being able to manage at a workflow level more what my agents do. But I think it's not so much a framework choice. It's like what problem are you trying to fix, and then you go from there. There'll always be new frameworks out there that will supersede the last. For example, anyone here had to work on Angular before? Cool. Angular market's disappearing slowly, right? It's going to Next, it's going to these others. It's still relatively popular, but it's not as popular as it once was before. Angular was the golden child, but as a framework, it's somewhat disappearing. Yep.
All right, sounds good. And I think we had a few other suggestions from the chat, but I think we'll leave it there on the chat. So does anyone have any other questions from the room? Otherwise, I'll switch to questions for you guys for the license. So I'll save one question for the online. So this is the first tour for the room. Okay, so let's start with something fairly easy. All right, so 2 anti-patterns from the talk. Whoever gets it first gets the license. Mention 2 anti-patterns. Yep.
Ansible and Jenkins.
That was technology choices. Do you want to take that as anti-patterns?
I think you said that right, patterns.
Well, they're technology anti-patterns because I hate them.
If you're happy to pay that one, then
Why not? It made everyone laugh. It's worth something.
Resume engineering.
Resume engineering, yes. And the calcified development.
Lazy
Yeah,
culture.
Lazy.
Yeah. I think we've got to give it to Ansible and Jenkins. That was great timing.
Come and see me afterwards, and I'll give license. And okay, and it's not all anti-patterns. What's one of the recommended solutions?
Event-driven design.
Yeah, he said my favorite.
That was the first one. That's very good. All right, and now, for the people online, we'll see whether anyone's interested. Yeah, so for the online people, if you don't answer quickly, I'll pass on to the room. So one more solution. If you answer quickly, then you can have the license.
Dun 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 dun.
Another countdown. You guys have got a bit of an unfair advantage to think about it.
I'm gonna set up my Discord, whatever chat you got next time I come in.
Just do it that way.
Do
Do it through a Discord bot.
Yeah.
All right. I think we'll just go with the physical room. So one more solution.
Architecture decision backup.
Yep.
Say again.
ADR.
ADR.
Architecture decision backup. Architecture
Decision record.
Oh, perfect. Thank you for persevering.
Sorry.
Sorry.
I want the prize.
Very much. So actually, we do have the complexity.
Mm.
We have the book and the 2 licenses. So,
Okay, maybe between the 2 people in the room that got it, you two.
we got.
I want to think of a number. The first person to say a number gets the book.